Assalamu alaikum guys, welcome back. Okay, so now in this video we have started out a new topic or a new chapter, I should say, redox reactions, and let's begin. Alright, so redox reactions, what does redox reaction, the term redox reaction actually mean? Okay, first of all, you must have an idea from your O levels, of course, you have an idea of what this is actually. Redox actually refers to any reaction in which involves oxidation or reduction or both, either oxidation or reduction or both. Okay, this is a definition that you must know in your A levels. Okay, so what does redox actually mean? A reaction that involves either oxidation or reduction or both. Okay, preferably both are actually, most of the times both oxidation and reduction are occurring side by side, but sometimes in some example questions, actually in the past paper questions, I've seen some questions in which only oxidation was occurring and the examiner called it redox, or only reduction was occurring and still the examiner called it redox and it was accepted in the marking scheme. So the definition of oxidation redox reaction is any reaction that involves oxidation and reduction. You can define it in this way, or you could say that reactions involving oxidation or reduction or both of them occurring simultaneously is called a redox reaction. Now, what does oxidation and what does reduction actually mean? Well, from your O levels you must have heard about these terms, oxidation and reduction, and you must have defined them as the gain of oxidation. Of course, the term oxidation, oxy refers to oxygen, so oxygen gaining process is oxidation, and reduction is oxygen losing process, reduction. Okay, yeah, this definition is correct, but this is just the first way of defining redox reactions. Okay, this is just one way of defining redox reactions or oxidation and reduction. There are three more ways of defining oxidation and reduction which you guys are expected to know, and I'm assuming that you guys have already done all the four methods, all the four definitions in your O levels as well. If not, now's the right time to learn, so let's continue. Now, after oxidation and reduction comes the second definition, which is in terms of hydrogen atoms or hydrogen gas, hydrogen. Okay, so basically it's the reverse of oxygen. Over here oxidation meant gain of oxygen. In terms of hydrogen, it means loss of hydrogen. Okay, loss of hydrogen is oxidation, whereas gain of hydrogen is reduction. Okay, so in terms of hydrogen the definition is gonna switch. Over there it was loss of oxygen for reduction, but in case of hydrogen it's gain of hydrogen for reduction. Then in terms of electrons, you can define both oxidation and reduction as well, because sometimes you don't have oxygen in a reaction, nor do you have hydrogen in a reaction, and you still have to identify that reaction to be an oxidation reaction or a reduction type of reaction. So how to do that? Then you'll have to look at the electrons. Okay, and electrons is the same as hydrogen. Okay, for reduction, it means gain of electrons, and oxidation means loss of electrons. Okay, again opposite to oxygen. And then finally the fourth term, or the fourth definition, which is the most important definition and the definition that applies everywhere, is in terms of oxidation number or the oxidation state. Okay, I hope you guys know what oxidation state or oxidation number means. Oxidation state actually refers to a number given on the basis of gain or loss of electrons that an atom is capable of. Okay, for instance, oxygen is capable of gaining 2 electrons to fill its octet, right? So its oxidation number is going to be -2 or 2-. Okay, in case of sodium is capable of giving away 1 electron, so its oxidation number is actually its charge basically. Okay, so the charge of sodium in that case is going to become +1 or 1+. Okay, oxidation number, if there is an increase in oxidation number or increase in oxidation state, we call that reaction as oxidation, and if there is a decrease in oxidation number or a decrease in oxidation state, we call it reduction. Okay, so now these are all the four definitions of oxidation and reduction. I will explain you how to identify or how to calculate the oxidation numbers or how to identify oxidation numbers, and then you'll be able to get a better idea of the fourth definition, and that will be done in the next video. But before I leave, I'll just give you an example. For instance, oxygen, okay, You've got 4OH. Okay, you've got what do we have? Carbon gaining oxygen, forming carbon dioxide. So what do you guys think? Carbon is gaining oxygen. Is this an oxidation reaction or reduction? It's an oxidation reaction because oxygen is being gained according to the first definition. Now, for instance, hydrogen is gaining oxygen and forming water. Now what? Which one is the oxidation reaction and which one is being oxidized and which one is being reduced? The hydrogen is getting oxidized. Why am I saying that? Because it is getting oxidized because it is gaining oxygen, and gain of oxygen is oxidation. Whereas the oxygen itself is getting reduced because it is gaining hydrogen. Okay, so you can explain both in terms of both the first and the second definition. Now, if you've got electrons and electrons are being added, for instance, you've got protons and protons are gaining electrons to form hydrogen gas. Okay, electrolysis. Remember electrolysis from your O levels? Now, in this case, if I were to ask you what's happening to the protons or what's happening to the H positive ions, are they being oxidized or are they being reduced? So, well, you can explain that in terms of either the third definition or the fourth definition. Okay, if you explain it in terms of the third definition, well, look at the protons or the hydrogens. The hydrogens are gaining 2 electrons, right? 2 electrons are being gained by the protons. Gain of electrons is reduction, so the protons are being reduced to the hydrogen gas. Whereas if you look at it according to the fourth definition says that if there is an increase in oxidation number, it's going to be oxidation, and if there's going to be a decrease in oxidation number, it's going to be reduction. So the oxidation number of proton over here is the same as its charge, which is +1, and the oxidation number of hydrogen gas according to the rules which we'll be discussing in the next video is 0. Okay, because elements, no matter in any atomic form, will always have a charge of 0 or oxidation number of 0. So its oxidation number is changing from +1 to 0. Okay, hydrogen is changing from +1 to 0. +1 to 0 means it is decreasing, right? It is falling from +1 to 0. It is falling, right? It is decreasing. So again, according to the fourth definition as well, it is being reduced. All the definitions will give you the same answer. Okay, third definition, it is gaining electrons, so it's reduction, and fourth definition, its proton number is decreasing, sorry, its oxidation number is decreasing, so again reduction. And this completes our discussion on redox reactions definitions, oxidation and reduction. After this, we'll be talking about the methodology of assigning oxidation numbers, the rules of assigning oxidation number, and the rules of calculating oxidation number, inshallah, in the next video. Thank you.